Alright students, welcome to week 4 of Health Science 349, Measurement and Statistics in Health Science. So we're going to step it up this week and next week just before our midterm. And so chapter 5 we're going to learn about different types of correlation coefficient and focus on one type of calculation, the Pearson's product moment correlation coefficient. So here we go. So our objectives for this chapter are to know the different types of correlations, know when to use, calculate, and interpret the correlation coefficient, specifically Pearson's product moment correlation coefficient, and we'll talk about that in just a few slides. Know how to interpret SPSS output for this type of correlation coefficient, and then also know how to calculate and interpret the coefficient of determination and alienation. So as you can see here, a lot of calculations and interpretations. So this is where the challenge comes in. If you think about this entire course, the basis of this class is mathematics. However, where I notice a lot of students struggle with this class traditionally is not necessarily the mathematics itself, because it's, for the most part, simple algebra, basic algebra. Where the difficulty comes in is the interpretation of these numbers, the interpretation of the statistics to make sense of it in the real world. And that's where the challenge is. So make sure that if you have trouble with word problems or understanding how do we interpret and make sense of these numbers in the real world in a practical setting, come and see me. Ask me for help. So let's jump right into it. What is correlation coefficient? Well, it is a test statistic. So a statistic, right? Think about statistic versus parameter. Correlation coefficient is a test statistic that describes the strength and direction of the linear relationship between two variables. So think about this. Let's break this down a little bit. It's a test statistic, so it's going to be a number that describes two different things. It describes the strength of a relationship and the direction of a relationship. And this relationship is between two variables, not two individuals, not two cases, two different variables. And one of the things that's unique about this relationship is that the relationship between these two variables is a linear relationship, where essentially as one variable goes up, the other one either goes up or goes down. And correlation coefficient is really a function of an individual's scores and the variability among these scores for two different variables, variable x and variable y. And we'll see in this calculation how each of these scores come into play when we're calculating our correlation coefficient. So here we go. Here's an important table to know. Types of correlation coefficients. If we look at the three columns, this is going to be variable x, let's say. So we have nominal, ordinal, and then interval and ratio. And notice that I have interval and ratio clumped together. The reason for this is that interval and ratio variables are our quantitative variables, unlike nominal and ordinal, which are our qualitative variables, no real numerical value. And then our three rows are going to be our variable y, with the same three levels of measurement, but really encompassing all four of them that we know. One of the things that we're going to focus the majority of this chapter on is the relationship between two variables that are both quantitative, that are both interval ratio variables. And this is specifically the Pearson's product moment correlation coefficient. But I do want you to know all of the other types of correlation coefficients depending upon the level of measurement. We're not going to go into these in great detail, in so much that we're not going to calculate or interpret them, but I need you to know when do we use these ones given the scenario, given the level of measurement for our variables. So here are some examples. Let's look at the first one. The correlation between gender and political affiliation. So we have two different variables, gender and political affiliation. So think about these. What level of measurement are these? Go ahead and take a few minutes and work through these 5 different correlations and see if you can identify what variable x and variable y are. I'll give you that now. Variable x is going to be your first variable. Variable y is going to be your second variable. You need to identify the level of measurement for each variable and then figure out which test, which correlation coefficient is appropriate to run for each of these 5 scenarios. Go ahead and pause the video and work through this. Come back when you've got your answers. Alright, so hopefully you actually worked through these 5 different scenarios. Give yourself the chance to practice this. So let's look at the first one, the correlation between gender and political affiliation. Well, gender and political affiliation are both nominal variables. For gender, we have male, female. Political affiliation, Republican, Democrat, Independent. None of these have any hierarchy or rankings, nor do any of these groups or categories have real numerical value. So they're both nominal variables, so we're going to conduct a phi coefficient. Second one, correlation between class standing, freshman, sophomore, etc., and GPA. Well, class standing, we see we have freshman, sophomore, junior, senior. Well, we know that there's some order there, and it's categories, but there's no real inherent numerical value. So class standing is going to be ordinal, variable x. And GPA, well, we know GPA can be a number, 2.0, 3.0, 4.0, 3.5, 3.23, 2.79. So it's a number, and we know that these numbers, as you go up and higher, that the better the GPA. And these numbers actually have real numerical value. So GPA would be interval ratio. So given that our variable x is ordinal and our GPA is interval ratio, we will be conducting a biserial coefficient. What about the relationship between income, which is defined as annual gross income, and marital status, single, married, divorced, widowed, etc. Well, we know that income, annual gross income, is going to be actual dollar number. The number itself, the marital status, single, married, widow, divorced, there's no hierarchy. These are just really categories. So this is going to be a nominal variable. So income, interval ratio, marital status, nominal, point, biserial coefficient. Scenario number 4, the relationship between subjective pain levels from 0 to 10 and quality of life, poor, fair, good, very good, excellent. Well, both of these variables are going to be ordinal in nature, right? Even though subjective pain levels have numbers, we can't really measure these numbers. A 0 to a 1 is going to be different distance from a 9 to a 10. And even so, you can't technically and objectively measure these distances. Nor can you really measure what poor to fair is and the distance between good and very good and excellent. So these are both ordinal variables, so we're going to conduct a Spearman's rank correlation coefficient. So our last scenario, the connection between major and support or opposition to war. And when I mean major, I mean health science, communications, biology. That's what I mean by major. And support or opposition to war. Strongly support to strongly oppose. Well, if you think about major, these are just groups, categories, so that's going to be nominal. And support or opposition to war, strongly oppose all the way to strongly support, as we saw in our previous assignments, is ordinal. So in this case, we're going to conduct a rank biserial correlation coefficient. So make sure you understand and know, given a scenario, what is the appropriate correlation coefficient to conduct. You're not going to have to do any of these by hand or interpret them or conduct them in SPSS, but you should know about them and when to use them given the scenario. And one last point I'm going to make on this slide. Notice that I use correlation, relationship, and connection all interchangeably to really describe the relationship between two different variables. So know when you see correlation, relationship, or connection that I'm really talking about the relationship between two variables, which then means we're talking about correlation coefficient. And you want to think about all the different types of correlation coefficients. We have 6 of them total: phi, biserial, point biserial, Spearman's rank, rank biserial, and then the big one that we're really going to talk about this whole chapter is going to be Pearson's product moment correlation coefficient.